So this is the introduction of the a implementation of a pavement management system in California. So I want to talk about the successes and the challenges. So the challenges later on, I'm going to leave it as the questions for your folks. Okay, so to preserve the bandwidth, I will stop my video, and so hopefully your folks have a lot more questions, so we can make this webinar a little bit more live. Like I said, for the past half a year, I didn't travel anywhere, so I think this is like a virtual tour for me. Okay, folks. With that, I would just start with a little bit myself. Right now I'm working in the Office of Mobility Programs. That's in the Division of Traffic Operations. Okay, so but don't be surprised. This is the PaveM implementation was done in my previous assignment. As the PaveM Office Chief in the Division of Maintenance. Okay. So a little bit agenda, and I will introduce you a little bit of existing practices in terms of pavement management. Everything and anything I talk about today will be on pavement management. Okay, so not too much on the traffic operations side, but here I want to talk about a little bit successes, and then later on talk about the challenges before I conclude. So we do have about an hour. And then I want you, strongly encourage you to jump in and anytime, okay, raise your hand, or Cheryl, you can interrupt me also, because I want to make sure, I understand my audience, and I don't want to lecture people, and so we can really use a lot of time out there to enter into the discussions, right? So I believe that's like a mutual educational process. And then, yes, Caltrans, we do have a very old pavement management system, dated all the way back to 1978. Think about it, that's about, almost how many years? 40 years ago, right? So that's an old PMS. And then that PMS is based on, only the current pavement condition information. Okay, so, the current and past information trying to allocate the resources. Okay, so what I mean based on the current and past condition will be, in the old pavement management system, we do have a manual team, like I think we have like an 8-person team. That 8-person composed mostly of transportation technicians. Their sole job is to go through the statewide, pavement network. Every 3 years, they complete the network survey one round. That's every 3 years. Okay, they complete one round of survey, and all those information will be used as the current pavement condition information, and together with the past as-built information, so that they can develop new projects and develop new funding programs. Where, when, and how they spend the money to bring the network level performance up to any, right? So that's the old pavement management system. Every 3 years, you have one cycle, and purely manual survey. I believe we follow whatever the LTPP, survey manual. Caltrans, we do have our own survey manual also. Everything is based on the pavement surface distresses, a little bit IRI, type of information, International Roughness Index. And based on that, Caltrans also have our own traditional performance measures. That is the needs assessment or identification, right? So we have the, ROBYG. That's based on the color. The red will be major structurally distressed, and orange is minor structurally distressed, and the blue will be red only, and then the yellow is non-structurally distressed, and good is good. Okay. So based on these colors having another connotation will be the treatment. Say, for example, the R, O, and B, right? The R and O, because they both are kind of structurally distressed pavements, so we have to use structural kind of treatment methods, right? So, and funded by a dedicated, funding source. We call it SHOP. That's a state highway protection and the preservation kind of protection program. Anyway, it's SHOPP. right? So that's the major funding source out there, for the structurally distressed pavement. And for the blue will be the red only. That means your IRI really bad, so people suffer, from bumpy rates, right? So it will be lumped into this R and O colored pavement. So we also using the SHOP funding, to fix those. And for the yellow, that will be non-structurally distressed pavements, for this type of thing. And also the good, we want to use, for the yellow, we want to use a little bit preventive or thin overlay or, chip seal, that type of thing, we fix the pavement. And for the good, we use them as candidates for preventive or proactive type of treatment strategies. Okay, so you see that the color is not only, a assessment as a performance measure, but also as a lead for the funding program and for the type of treatment strategies. Okay, so that's why ROBYG, every time when we talk in California pavement area, we do have specific connotations there. Remember in MAP 21, that's the MAP 21. I hope everyone understands that's a federal funding bill. That's called Moving Ahead for Progress in the 21st Century Act, right? So the MAP 21, they issued a specific, good and fair poor kind of performance measurement system that has posed a big challenge to the existing ROBYG kind of traditional performance measures. And I may touch on later a little bit on that. Okay, so, and then the future prediction, will be based on, human judgment with field visits, and definitely we have a lot of models out there, but I'm not sure it's got incorporated into the old PMS. Okay, and then the TYP will be the 10-year plan process. So the 10-year plan process mostly will be based on the current condition and past condition, and then venture out based on our engineering judgment, okay? And together with our district engineers, headquarters and districts, we work hand in hand to develop the 10-year plan process. Remember, we're talking about a 10-year plan. That's really a big venture out there, when you trust human beings' judgment, right? So that's in the old PMS. Any questions so far on the old one? Okay. So I hear Nan, and you can hold your question also if you prefer. No worries for me. I can do both. Okay. So, but in the year of 2011, Caltrans starts to test it out. The first round of automated pavement condition survey. It's not manual anymore, and we use a system. It's a very prevalent this year's commonplace. And it's done by a company. They offer not only this front view. You see that the three, I can annotate a little, maybe using this thing. You have the left, the center, and the right kind of view, and we do have the GIS map out there, and we do have the pavement surface. This is the 3D view of the pavement condition thing, and this is the IRI and plots, right? So this is very, very commonplace, but in 2011, it's not as commonplace. But UC Davis at that time, helped us, did the QCQA of the entire state. Okay, so we did inch by inch statewide, on all the main line, lane by lane, and we plan to do it, every year, right? So, but in 2011, I think that's the first venture, and then later on we have 2015. 16, 2018, 19, and now 2020. So we have all those many sets of data already. Okay, so and starting from 2019 year, we also collected, automatically all the on-ramp and off-ramp connector information. So basically now, starting from 2019, we have full coverage statewide. The state-owned pavement. So our pavement, we have about 50,000 lane miles out there. If you add another 10,000, the ramps and connectors, so we total about 60,000 lane miles out there. That's a lot of pavement there. Okay, so and then this is the automated pavement condition survey. We have the data in. You see that and this thing can be done in about half a year. So really a improvement in data collection, especially for the current surface pavement condition data. Okay, so we did a GPR, ground penetrating radar investigation throughout our highway network. I think that's in 2012, like that time frame. And then we interpreted a lot of data so that we can gauge into the structural situation statewide, right? But that's only the one-shot deal. And later on, we don't have any network level, kind of study of the structural situation. So that's one of the challenges, later on I'm going to touch upon. Because the current pavement condition, we only have the surface distress information and IRI. And for the current PAVM, we call it the current Caltrans pavement management system. We call it PAVM, and then it is a commercially off-the-shelf kind of package, and it is a LIM-based PMS, MIP 21 compliant, and used automated APCS data. So, and this PAVM will serve us big time in terms of developing the asset management system. Okay, so we already use this system to develop the 2017, 2019, and now the 2021 10-year plans. So every time when I talk about 2017 year 10-year plan, in fact, it covers from 2017 all the way to 2026. Okay, so that's a 10-year cycle there. In fact, it covers from 2018 to 2027. Okay, so and for the 2019, it covers from 2020 to 2030. So we are doing 10-year plans in Caltrans, okay? And we use PAVM doing just that as an asset management tool there. And we also use PAVM to do the monitoring progress. Because anytime you develop a 10-year plan and people follow the plan to develop your projects, you also do post-evaluation, you also do real-time basic monitoring. Right, what the system is doing, because every 1 year you do have your APCS or the automated pavement condition survey every 1 year, right? So that's the thing, we are continuing monitoring all these projects down the road, and so we have a full accountability, right? So that's the 10-year plan process or asset management process implemented in California. And the PAVM has been one of the strongest support, I say, for the entire asset management program, because we have 4 assets. Pavement is the largest asset. Luckily we have PAVM implemented to support the entire MIP 21 requirements. And in California, we do have a state law we call it Standard Bill 1, and that's also asking for accountability, asking for data-driven performance-based management practices, right? So that's all asset management related. And for the APCS data, let's just talk about the data. This GIS integrated pavement portal, that's what we developed with the assistance of, California Pavement Research Center. That's called UCPRC, that's UC Davis, right? So when we have the data out there, the data is, see that you can see the entire network. This is the San Francisco Bay Area. And you can also continuously delve deeper into the data. This is the data, basically at the aggregated level. When you see the whole thing is yellow, in fact, that's only by direction, right? Only by direction. And this little piece, see that this piece, if you enlarge it to here, from here, you can't see too much of the detail. And here you will know, your data is split left and right. Well, if you continue to zoom in, you are going to see our data is lane by lane. And most of our pavement management systems throughout the state or even the world, they are not really lane-based. Okay, they are only the rightmost lane-based or the worst lane-based. But California is like at the 10th mile level, that's a MIP 21 requirement. And for every single lane, we have the information. And all these little segments out there, it's about a 10th mile. Okay, so that's the level of detail, this pavement management system all about. It's a lane-based management system. And unfortunately, y'all folks can't access the data, but here I have a little thing to show you, maybe to show you a little bit, on the fly, so you can see what this whole thing is all about. We integrated, the base map and together with the post-mile system, and together with the as-built condition, as-built projects, see that this is the post-mile stuff. Okay, all these black dots, all these little black dots, it means every 10th mile in the post-mile system. Okay, and these are the lane by lane information. And then you can also see, we do have this type of holes out there, right? The hole means a structure because we only collected pavement information, right? Now you can see the information becomes lane by lane, direction by direction, right? And then based on that, if you click, you do have the project information out there. See, that's where, for the surface information at this time. And this one can also trigger all the way, or can also link with the APCS data on the fly. Basically, you click on the post-mile location, click on a certain condition, little 10th mile information, you link you all the way to the images of the pavement. You think about it as a pavement program or like a pavement engineer, what additional information you need. So basically, we're designing this one as a portal, as a like a working bench for our engineers to see, wherever you want to go, as long as you can click on this piece of pavement, you are not going to see, not only going to see the surface condition, you're also going to see the as-built information, okay? And you are also going to see, you can travel along the pavement, right? So that's when I work in the PAVM office, the vision of our office, basically bring the data, at the fingertip to our pavement engineers so that they can help program or review the best job, okay, making sure our project got located at the correct location, the correct time, and the correct type of treatment. And definitely you can also, export all this type of information, through the tabular below information, okay? So but anyway, so this is just like a short demonstration of what we have, in terms of, the existing condition, in terms of the as-built, and in terms of, the post-mile system, things like that sort. I just don't want to bore you, but give you a teaser what we have integrated, okay? With the PAVM system or any PMS, I think the main purpose of the system is to show the a piece of pavement, and it's the entire life cycle, right, from cradle to grave. So basically, here is the situation. I can show you, a piece of pavement. It's in Orange County, and from the post-mile 24 to about 39, about 15 miles, right? And in this PAVM system, we have for the 2015, the condition on the surface everywhere will be green colored. Only a little bit, yellowish and a little bit blue. Remember what blue means? It's just bumpy ride, right? So because the color means something in California here, and then this is left side, this is right side. So after we have this piece of pavement, when we put it into PAVM, and when we spit out information by 2020, you're going to see this greenish pavement, everything, the color start to shift, right? We call it deteriorate, right? So you see the green change to yellow, maybe yellow change to orange, and then maybe the blue, just grow bigger and bigger, right? And then by the year 2027, because we're talking about, a 10-year plan, right? Remember I talked about 2017-year 10-year plan. That's from 2018 to 2027. That 10 years out there, you'll see, a lot of the pieces start to become red, okay? So within your system, I think all PMS is doing is trying to show you the entire life cycle and how pavement is deteriorating, and based on the deterioration, so we can start to develop projects, right? Start to develop projects. Say, for example, right now, this piece, becomes very much reddish, right? See, for this piece, very reddish. So probably you want to do a project, using maybe the sharp funding. That means structurally damaged. And for the rest, you only have a little red, you may be able to do, a localized, say like a dig out type of treatment, right? For the red, and then for the primary yellow, you may be able to do a little bit thin overlay or chip seal type of thing. You can just fix it up with it. So that's the entire process of pavement management. Okay, at least it's in my mind. All right, but this thing, the PaveM enables future condition. Basically, it provides you with a crystal ball, so you can see, when, where, and how you are going to fix your pavement. All right. So for the 10-year plan process, we also use PaveM to develop, a total control, a total investment control. Total investment will be, PaveM tells me how much money do I really need for this 10-year plan, and then why this need is justified, why this need is optimal. Okay. So what we did is that we use the PaveM to run multiple scenarios out there. Okay. We run the 10-year plan investment needs versus a 20-year plan investment needs. Okay, so these two coordinate system, your folks have, if you first time read this one, you got to be really focused. This is 10-year plan investment dollar. These are the 20-year plan needs dollar. Okay, so when we plot these two charts together, we see a U-shaped curve. Okay. And why it is a U-shaped curve is because, if in your 10-year plan process, if you invest a lot more, for example, you invest a lot more in your 10-year plan process, that means a lot of your pavement, you are doing thick overlay or medium overlay like that, right? You are not doing much preventive type of treatment. Okay. That means your 10-year plan, you really spend a lot more dollars like this point representing, right? At this time, if your 10-year plan, you invest a lot more. In your 20-year plan, you really kind of also need a lot more. You also need a lot more money, okay? Well, the other thing is that if you, in your 10-year plan, you only use maybe those type of chip seal, preventive type of treatment, when you evaluate your entire system again, you see, oh, in 20 years, you're really need a total investment similarly to you invest a lot more in your 10-year time. Okay, so there is a optimal point, for a good combination of strategies in your 10-year plan. You do have, see, like this dot, two dots representing. You do have that optimal time. When you invest in a good combination in your 10-year plan, you also lead to a very low total investment in your 20-year plan. So that's the point we are seeking, right, for your 10-year plan. So that's why, PaveM really enables you to identify the optimal total funding, okay, for a 10-year plan. So that's something, we really take a lot of pride in, and then so based on a life cycle cost point of view, and probably from the sustainability point of view, you will see that, you have this optimal investment out there, okay? So this is a good chart. And this is another chart, PaveM can help revolutionize will be, when you talk about this is the total number of years out there, that's the total number of investment. And then all this light blue bar is something already happened. The blue portion, the light blue portion is what you use as maybe the structural dollar, okay, structural fixed dollar. And the dark blue is something, thin overlay or like a maintenance spending, okay? So these are already occurred. So this chart is showing you the spending plan. All these vertical bars, they are spending plan, okay? And the light blue and dark blue is the spending already occurred. And the right bar is something in the pipeline or in the programming cycle. And all this light green, all these bars, are the future investment, okay? And we're inching along every 2 years, I believe, because every 2 years we update the 10-year plan, right? So these are the investment. And in this chart, the beauty is that we plot the network level performance, that's the line, together with your investment. So when you see your investment is higher, definitely investment is higher, definitely you see the distressed pavement, reduce or decrease, right? So at least logically, it's correct. All right. So in PAVM, we can plot out, the 10-year plan total investment versus predicted network performance. Okay, so that's something, PAVM can also help us. And this chart is so critical, in our 10-year plan and in our asset management process. Okay, so that's something, we really like very much. All right, and then PAVM also help us to do not only network level grander scheme of things, it can also do individual project evaluation. And this becomes even more critical for, a certain project review. For example, this is in the San Francisco area, Route 101, in Santa Clara County, about 16 miles of road. Okay, so this one might be you can do lane by lane even, because our system is lane by lane, right? So now let's see how this piece of pavement is performing using the 2016 data. See, this one is 2015 here, and then 16, right? So the ROBYG colored, remember I already introduced you the different color and what they're meaning, okay? So for this piece of pavement at the beginning, you don't have much of a red colored pavement at all, okay? But red pavement will pick up later on, right? And then when you see this piece of pavement, at the beginning, it's very, very greenish, or at least a green accounts for 70% of the entire post-mile range, right? And this green start to dwindle like that, and the yellow start to pick up, and yellow changes to orange, and orange change to red, right? Okay, so based on this chart, what kind of improvement strategy we can strategize? So the number one thing is that you definitely, if you currently you don't have any money, you can wait until the pavement become crappy. That means you wait until the red colored pavement to increase maybe to about 20%. That's our internal threshold, right? So by that time, you probably need to rebuild, or at least you want to do rehab. Okay, you want to do rehab. Or you have a lot of other options there. You can control the dwindling of your green pavement, right? By doing preventive type of intervention. For example, you can intervene maybe by 2021. You start to do proactive type of treatment so that you bring your green component up, right? See that green is dwindling. You can also jump in to do thin overlay type of treatment. Maybe you fix the yellow, right? Because see here, your yellow already have that much. Probably you want to do something out there, to fix it up, the yellow. Or you can use a medium thickness type of treatment, or medium thickness type of overlay to fix all this orange type of pavement. When they say maybe go beyond about 40% threshold, right? So you also see that for this orange line, it stay flat for a little while. That means what? When it stay flat, that means it gives our people a lot more floating time to program a job, isn't it? To program a treatment, isn't it? So you can do the treatment now, but you can do the treatment maybe a little bit later. So you have 3 or 4 years out there, like a floating time for you to play around, okay? So this type of evaluation, man, is really lend the pavement engineer a lot of informed decision-making points. You can decide what kind of treatment you do, and you can also play into this post-mile range to do lane-by-lane analysis to see which lane you want to fix it, or which 2 lane you want to fix it first, right? So this is very, very informative for us, when we use PaveM. So that's something, we really like. And also with, this is a deterioration rate, without PaveM, I can tell you, our pavement engineer have a lot of challenges, in developing this type of, deterioration rate or the transition between different states. Remember, the green goes to yellow, and yellow goes to another yellow, and then this yellow goes to red, and red come back to green, right? Anytime red come back to green, that means money, isn't it? Isn't it? Anytime yellow comes to red, that means natural deterioration, right? And yellow goes to green, that means money also. Basically, you have to use money to buy performance. That's why in the programming world, in at least in our office, in our practice, we view, pavement management essentially is using money to buy performance. And that's why the deterioration rate is very, very important. These things from green to yellow, these are natural deterioration rates. And if you want a yellow pavement to turn into green, you have to pay for it because you have to pay through certain projects, right? And then the deterioration rate, all these rates, how the engineers come up with all those things. With PaveM, it becomes a little bit easier, but we don't want to just trust ourselves on this type of deterioration rate because it's related to the modeling, right? How you are modeling your pavement, that's related to your deterioration rate. But here in PaveM, last year, one of my staff, Dr. Xiang Su, a lot of people might know him. He developed this paper, and we presented at the TRB. We used the APCS data. We validated this deterioration rate. That's a large-scale validation effort, across the state. So, and what we validated, you just see this green, yellow, and red. Okay, so let's just only focus on the green, yellow, and red. Don't focus on the good and fair poor, things like that, because good and fair poor belongs to the Fed side. And then what we validated is from the green state to the yellow state, how this curve, how this slope might be, right? Because the slope representing the deterioration rate, isn't it? That's from green to yellow. And similarly from yellow to red, right? So we also want to validate that slope. Will it be correct? Will it be wrong, right? So that's what we did. The basic setup is we use the 2016 data, APCS data, and then through PaveM's model, we predict the 2018 year performance. Using 2016, predict 2018 year. And remember, we also have 2018 year data collected, right? Because every 1 year we send APCS van to collect all those data. And then we compare the two 2018 year, one predicted, one measured, right? So if they compare favorably, that means like in this chart, if they compare favorably for this thin overlay type of treatment in terms of IRI, they compare really favorably. We say that the deterioration rate for IRI is good. We can trust it. Okay, so because they really align the 45-degree line very well. However, for this APCS, for this cracking, especially for the alligator type of cracking, they really didn't match up that nicely at all. That means what? That means internally, our a deterioration model, if we want to improve, probably we want to focus on the alligator type of cracking modeling, right? So ever since last year, I moved out of division maintenance, and then I think they are continuing to launch that type of effort to validate this type of performances. Okay, because I can tell you that 50% of the effort in any PMS probably is the performance modeling. Okay, so folks, if you didn't really validate your performance model, I would strongly recommend you to do so. Okay, see, this is the modeling piece, and then related all the way back to here. Okay, back to here. the deterioration. And also back to here, right? And anytime when you have a deterioration rate change, that means what? Means dollar, means money. So that's why it's so critical. Okay, so now I move to the challenging part, will be the modeling. How in the system, in PayVAM, we are modeling. And I just using one example. For example, we have implemented a lot of maintenance type of strategy, right? We call it HM strategy. And if you are a payment engineer, you know a lot of times you place a thin overlay on top of a thick overlay, you have a hard time modeling the practice, modeling the performance of that thin overlay, right? So in PayVAM, you know, right now, suppose we already have a thick overlay type of pavement underneath, and later on you want to add a, say like you have a distress, and you want to add a thin overlay type of treatment maybe. So how you are going to model that performance for that thin overlay layer? You have so many ways of modeling it. Say like when you have this second one, you can model it assuming, you know, this thin overlay really bring up the performance, right? Because see here will be the performance, you bring it up, and then the combined thin overlay and underneath thick overlay perform exactly the same way as the underneath pavement. Okay, do you think this one is conservative or aggressive? I believe it's a very, very aggressive. I think so. I think it's a little bit aggressive. Okay, so let's see some other ways modeling this thing. You can assume, say, like the number one. The number one, basically, you know, you assume nothing happened. Nothing happened. You just, you know, after you place a thin overlay, the curve didn't change at all. Okay, that means you totally eliminate or ignore the performance of a thin overlay, and you ignore the performance contribution from a HM maintenance type of strategy. And this one is like a little bit exaggerating of the performance because you are lengthening the total payment life by that much, right? So you have another way of modeling it will be you model based on only the top layer. See that? This is only you model based on the top layer. And that's very wrong, isn't it? Because, you know, your underneath payment will last previously, you know, to the year about 32. You know, now, after you put a thin overlay, you know, it performs at year 28, right? So that's like a no good scenario. And in our model, in our system, we model it this way. We call it the N-year model. You can specify based on your experience, you know, how many years a thin overlay might last. And then you put that year into it, and then you assume a straight line dwindling of your model. Okay, so that's another way of model. Basically, it's in between this line and in between of this purple line here, right? So that's something we are modeling there. But again, you see that when this green line in the future years will come back to the purple line or the major curve line there, we are ignoring the thin overlays contribution to lengthening payment life, isn't it? So that's something, you know, we are still out there, you know, have a hard time, and we try to, you know, improve. And probably today's 20-something participants here, you know, I really want to challenge your folks how you can give a good model, okay, to model thin overlay on top of a thick overlay. All right, so I will talk about that's a challenge. Okay, so the S chart, I don't want to focus too much because I already published it, you know, the numbers and presented multiple times. Basically, this is as-built history management, okay? Remember this challenge, okay, guys, this is a modeling challenge. And then the following part, I will focus more on the as-built, and then I will show you some of the initial results, you know, I developed, you know, in terms of, you know, the as-built data mining, okay? So for the H chart, that's basically the data visualization type of thing, and then every DOT can follow. and then you just plot out your project like this type of thing, and then you also plot out your performance. Here is the type of pavement, and here the number of years, so that you will see any piece of pavement, it's a cradle to grave. Okay, the past projects, current projects, and the future projects together. And again, this is like a mahjong table. Okay, so you can see, the cradle to grave of your pavement, and we call it like a working bench. Okay, like a mahjong bench. Our pavement engineers become the player, so that they can move around all these tiles, all these bars around to figure out the best time, the best treatment, and the best location, right? And all these things coming out of PAVM, and you can put it back to PAVM to help evaluate the performance. Okay, so that's why it's a very interesting process, in the pavement management area. Okay, so here is the as-built database. I have about 35 years, and these are all the project numbers out there. You see over the years, starting 83, we have done a lot, and you see naturally the increase of this project number. We really increase. And if you see the limb mouse, we are doing more and more limb mouse, across the state. Okay, definitely, one reason will be, here, our system in the 83, 84 year, our system is pretty good. And with the later on years, our system become poor and poorer, you need to pour more and more money. People might ask for why here at Big Valley in 2003 and 2004. Why is that? The Big Valley is because the 2000 dot-com bubble, okay? When you see this year in 2000, we really have a lot of investment. We know the dot-com bubble bursted in 2000, 2001-ish, right? But see, the impact you didn't see, okay, or the dip you didn't see until 2003, 2004, is because, when at the dot-com bubble burst, we already have a lot of projects, down the road programmed, okay? So this is the situation for the COVID-19, okay? So I believe the biggest hit is not now. We're not going to see the hit for this year and next year, but the hit is going to be seen in the future years, maybe I think 2023, like that. Okay, folks, so if you work in the consultant world, academic, you are getting DOT projects now, don't be surprised. But you have to be prepared for your future dip in the DOT funding. This is the treatment frequency. I just want to show you, what are the major, the top 10. The top 10 treatment accounts for about 85% of our past history, okay? And the top treatment for AC is chip seal. So across our 50,000 limb miles there, we see a lot of chip seal there. And then I believe my slide will also be posted on the YouTube type of thing, so you can delve more into it. And then you will see for the AC pavement. Okay, so this slide and the next one, you want to pay attention to the comparison between AC and PCC. For AC, you see a lot of green. Green is chip seal, right? So you see a lot of chip seal. You can see that. Okay, that's for AC. And especially in the early years, you see in the early years, 1980s, what Caltrans are doing, mostly are chip seal, because our system is pretty good. However, later on, when you see here, a lot of the bar is the red type of thing. What do they mean? They mean a lot more money, because they mean rehab, right? See that the rehab really start to take over. That's for the AC pavement. Let's see for PCC. For PCC at the beginning, you really don't have too much to do. Slab replacement, that's a collective. Most of the time, see that's a slab replacement. That's most of the time we do. And only in the later years, starting maybe from 2000 year, we start to pour money, to do the grinding and to do the PCC lane replacement. You see the red. Well, folks, you know how much it costs to do PCC lane replacement, right? However, when you see the top pin treatment for PCC pavement, you really only have 4, right? So you have the CISO, you have PCC, you have the Grand. The only corrective type of treatment we have for PCC is slab replacement. So apparently, we short of those type of proactive treatment strategies for PCC pavement. What do we do with them? But slab replacement, right? What do we do? I mean, that's a challenge. Okay, why your traditionally kind of lab or center, can you come up with any, PCC type of proactive treatment so the thing will not need like a slab replacement type of thing, right? So that's what I can see from our history. This is a very interesting history, 35 years. And I plotted out, this is the limb mile for AC pavement, okay? The limb miles we traded over the years. And then together I plot with the, this is a very interesting chart. People will, really pay attention. On the right-hand side, the second axis, I show percent distress limb mile. That's all these red dots, okay? That's the performance of my system for AC only, okay? And then these 2 lines. The green, the little blue line shows you the heavy maintenance type of treatment. And the little orange line shows you the rehab type of treatment, including the medium overlay, thick overlay, AC lane replacement type of thing, okay? So you will see in the early years, really, we don't need to do a lot of rehab type of treatment. And most of the treatment are kind of HM, okay, maintenance. And in the later on years, you see that the orange line start to pick up. The limb miles start to pick up, right? And let's see the performance. You see the performance, the higher the red dot, meaning the poorer the performance, right? Because it percent distress limb mile, isn't it? And only when you, after this 30 years, I believe this is starting from 2017. See, here will be, starting from, let's see, 1987, I believe. Start 1983. 1983, if you added about 30 years, starting from 2003, only by 2003 or 2013, you will see, the drop of this red dot. Meaning after all this investment, we start to reap the benefits, right, of the AC. So that's one point you want to see. And then let's compare with the PCC side, okay? So remember this chart on PCC, you will see that the light blue, again, the blue will be the maintenance limb miles. You see the maintenance limb miles really, keep flat, and in the recent years, they even dwindle the maintenance. That means a lot of our PCC pavement start to be needed to be replaced or through rehab type of treatment, right? And then by the year 20, something out there, or 2005, like that, our pavement really reached the worst state, and then we start to come back, right? And with all this rehab type of investment, remember, folks, it's orange line representing rehab investments, okay? And you see the lack of, maintenance limb mile. Most of the limb mile is rehab limb mile. You see that concrete limb miles we did. Most of them are these concrete limb miles, okay? And let's see, the next one will be even more interesting. This one will give you the trendy for all these past 30-something years. Let's see, this one will be the year, and this is the AC treated limb miles on the left side, and this right second axis is PCC treated limb miles, okay? I plotted the 5-year moving average, so you will see a little bit better of the trend. Let's see the thicker black line. That's for the AC pavement, okay? So you see, at least you can see 3 major waves of action. The first wave is a very minor wave. See that? That's for pretty good pavement, right? At the very beginning, see the AC has a little bit wave. As long as we intervened a little, the performance start to come back, okay? Start to come back. And then the limb mile very soon take up. See, everything we talk about is the traded length mile, okay, guys? The traded length mile and together with the year. So the traded length mile pick up very, very quickly after the initial thing. The initial thing didn't last many years before it pick up again, and then it dropped, and then very, very soon start to pick up again. Okay, so it looks like for the AC pavement, we almost never stopped, more than 2 years before we had to pick up the wave again. So basically a lot more need. And you see this line, it's crazily interesting that this line, or the total length mile we are trading, just continue to grow. If you fit a regression line out there, it's growing by about 3% a year. Do you think this trend is sustainable? In the long run, I mean, this whole thing just need more and more and more, isn't it? I mean, that's something bad from network management point of view, isn't it? This is not sustainable. If you see PCC pavement, that's even more frustrating. Yes, at the beginning, you didn't the short wave really lasted for many years, right? The short wave, yes, it picked up the length miles, but it become kind of flattened out a little for many years. But you see for the pavement, PCC pavement, the total length mile really pick up big time. And then before it drops, and definitely, see all these length miles lasted for many more years than this little short valley, right? That means PCC pavement, after you fix it, it really lasts you many more years than the AC pavement before the next trend comes in, right? And then the funny thing is that the AC pavement and PCC pavement, they almost suffer from the same slope. That means what? They deteriorate almost at the same time, right? So if you think Caltrans picks the correct length mile to do, isn't it? From year to year. I mean, that's really not what we want, right? We want PCC pavement. After you fix this trend should be a lot more flatter, right? Than this trend. Will it? That just, based on the length miles we did, or based on the past maintenance and action practice, that's what we can observe, And I do have some additional numbers I'll show you. Oh, the IRI definitely come back a little, IRI. I don't want to focus on this IRI thing. I want to focus on this AC and PCC, okay. This is the length miles. If you see for AC pavement, okay, for AC length miles, definitely over the 35 years, we did a lot of AC. We did 45,000 length miles of AC. But 3.5% of those length miles are preventive, 3.5% are corrective, and only the rest is about, the rehab. Okay, the orange color is medium overlay, okay? The red will be thick overlay. Okay, so that's for AC pavement. And AC pavement, every year we are doing about 12.3% of our total length mile. That means almost every 8 years, I cover my entire network once, no matter I paint it thin or paint it with only one layer, or I do a thick overlay. That's for AC pavement. Okay, now let's see for PCC. PCC similarly, the network coverage ratio, almost every 8 years, 8-something years, you will still need to paint your entire PCC network again. This is crazy, right? This number is interesting. And then for PCC pavement, a lot of the length mile you have to paint by doing rehab or doing, this type of CAP-M type of job, or medium overlay equivalent type of job. Okay, so a lot of the percentage, network coverage percentage, centered around rehab type of treatment instead of preventive. We don't have any preventive. Only a very 3% or a quarter of this network coverage thing, we do corrective type of maintenance. That's a slab replacement. So that's PCC, okay? But again, everything added up together, 8-point-something years you will need to paint your network again. Well, the challenge is here for your folks, how you can lengthen the life of my network. Everything I talk about today is based on network level analysis, okay? So don't use a project specific thing to challenge me. This is the cost level. It's even more alarming, okay? So for the maintenance and the rehab type of ratio for AC pavement, it's 30 to 70. Well, for PCC pavement, it's 2 to 98%. That's the ratio. Basically that's the maintenance versus rehab type of treatment, because most of the PCC pavement we use rehab type of treatment. Okay, so that's where we are in California. So that's the almost the last slide I got. I spent about an hour to go over this set of slides, and this is a minor summary. I talk about our payment system, how we implemented developing the 10-year plan. I also talk about the challenges in terms of modeling. I talk about the challenges in terms of how I can lengthen the life of my network using the past 35 years numbers, right? So as this center is traditionally, you are talking about sustainability. I don't think every 8 years I have to paint my network, it's very much sustainable. And especially for this slide, I really want your folks to kind of, pay a little bit more attention. Your network, basically is growing at a 3% a year of the lane miles that you need to do or you need to treat. So how we can really turn the trend of this line, turn the downward trend, can we? That will be sustainable, or at least, we maintain kind of a leveling, right? So we really need to reduce that 3% a year increase of my lane miles needed to be treated. Okay, I will stop here, Cheryl, and then Dr. Shi, back to you. Thank you so much for the invitation.
Thank you, Dr. Wang. There are a few questions in the chat room. Can you see those questions, or would you like me to read them?
Read it out. Let me see whether I can see it in the chat. Yeah, read it out, please, for me.
Okay, happy to read them. It is nice to use automated PCS. Could you give us more details or elaborate?
Oh, that's a commercial process. So that's why I didn't focus too much on the APCS side, because yes, it is a like I showed you this. This is really, you have a van, commercial van equipped with a lot of laser sensors out there. Through one pass, you can collect the cracking information, international roughness index information, and the faulting information, rotting information, everything you need basically, per Mach 21. And it's at a highway speed so that you can complete the full network in about 6 months. So our requirement is every 6 months, you have to turn around. Within 8 months, you have to deliver all these reports so that we can start to use current year's information to develop, the 10-year plan, things like that. So anything specific, if you'd like to know, on this APCS, definitely reach out to me, email me. Thank you.
Okay, thank you. Another question, could you explain a bit more on how you predict the pavement deterioration? Does this consider the pavement design, traffic loading, weather maintenance, actions, etc.?
For this deterioration at this time, not really. Okay, so the only thing is that what we use, all these models, okay, I should pull back on that. All these models are owned by UC Davis. Okay, UC Davis are our strong partners, and they are developing all these models for us, including AC and PCC type of strategies out there. Definitely, they will consider all this loading, the truck loading, lane motion, data, stuff like that. And definitely they will consider, our model, or the distress model, is the individualized. Okay, so our model, if it is talk about cracking, we model, the longitudinal cracking, alligator cracking, and lateral cracking also. Okay, for PCC, we also model, different type of, cracking individually. And later on, we add them up. So that's also something different because the modeling process is not an aggregate process. In fact, it is a disaggregated process. So we also model IRI separately, model routing and faulting separately also. So that's what we do modeling. And all these models, they added up aggregatedly, in PayVM, and then we produce the type of indices, right? And then for every red type of pavement, you do have a definition of a red, right? If it is, we define it as, say, alligator for AC pavement, your alligator cracking, you have to exceed about 30%. Okay, we only count on this wheel track alligator cracking, okay, and measured by length. Okay, so that's very detailed. But for the red pavement, AC alligator cracking has to exceed 30% before you call it red, and you have individual definitions for all these type of things, right? So when you talk about the transition or deterioration rates, you predict individual indices out there, and then you aggregate them, and then you kind of reach a categories, reach a color code before you can have this type of prediction of your deterioration. It's a very complicated process. I'm not sure I make myself totally understood. Go chime in, okay, if you need.
Okay, thank you. We have two more questions. On slide 13, could you give more details on the pavement conditions? Do you use any composite pavement condition index?
No, there's no composite thing. Like I said, in our system, everything modeled is individually. Even for cracking, you have a separate type of cracking model, right? Alligator is its own, and then longitudinal it's its own. And I believe we do have some, different definitions there. And we do have the APCS manual, and I do have anything else. If you need, I can you can reach out to me later on, and I can find out for you. Okay, we didn't use any composites like PCI, PQI, all those type of things. No, nothing.
Okay, last question. On slide 26, where does diamond grinding fit? Is that considered a corrective maintenance for PCC?
Yes, I believe so. Yeah, the grinding, I believe I have one point. I believe I have like a little chart. Oh yeah, here. Let's see. Do I have anything here? You do have a grinding somewhere. See slab replacement. Do I have a corrective? I believe I do have a grinding somewhere. Okay. This is microsurfacing grinding. We should have a grinding. Oh, here we go. See, that's a grinding preventive. You also have grinding corrective. Okay, so that depends on your thickness, your grind. Depends on whether you use a grooving or use just a typical grinding. That's a diamond grinding. We didn't do too many of those. It's based on the past 35-year history. But nowadays it really pick up.
Okay, we just had one more question come through. What is the pavement design year for AC and PCC in California? During this 35
AC is 20. Yeah, AC is 20 years, and PCC is right now is 40.
Okay, during this 35 years of PMS data, is it because most pavements have passed or reached the design life, so the treated lane keeps increasing?
Possible. But again, when you see all these things, if you think about a grand plan, how you can improve your sustainability, you probably want to increase your design year, right? So every 20 years you do it. Can you improve it to 25 years for AC? Can you do 100 years for PCC? I mean, that's some of the challenges, really lay in front of us, right?
All right. Well, that's all the questions that are in the chat room right now. So
very good.
Thank you so much. That was an excellent presentation. If you have any questions, you can feel free to email Dr. Wang. And as I said earlier, this is recorded and will be on our website in just a few days. So thank you everyone for joining us, and hope you're all well and doing good. Thank you so much.
Thank you. All right. Bye-bye.
Bye.